base of the ray diagram, you also need to know rules for making ray diagram. And the rules, there are 3 simple rules for making ray diagram. Remember students, this is also a very important question for your exam. The question is something like this. What are the rules for making ray diagram of a concave mirror? So let's have a look at the rules for making ray diagram. The first rule, it says, if the incident ray is parallel to the principal axis, then the reflected ray passes through the focus. Let's see. For understanding the rule, first thing that you require is the base diagram. Now the base is ready. Then I need to place an object here. This is an object. In ray diagram, an object is represented by an arrow mark, and the head of the arrow is labeled as A and the tail of the object is labeled as B. So this is AB. So object is labeled AB in ray diagram. Now the object, when you draw, the object is one line of your book. I repeat, it is one line of your notebook. Now coming to the rule for ray diagram. The rule is very simple. If the incident ray is parallel to the principal axis. So we have an incident ray which is parallel to the principal axis, right? So this is the incident ray that we have drawn. Then the reflected ray passes through the focus. Obviously it is a mirror. The ray is going to reflect back. When you're making the reflected ray, the reflected ray will pass through the focus. Now, when you make the incident ray and the reflected ray, you have to show the direction of incident ray and the direction of reflected ray by making an arrow there. That is the first rule. Coming to the second rule, which is exactly opposite of the first rule. Let's see the second rule. The second rule, it says, if the incident ray passes through the focus, then the reflected ray is parallel to the principal axis. Again, I make an object here, labeling it as AB. After that, if the incident ray passes through the focus. So we make an incident ray which is passing through the focus. Now, after reflection, the ray will become parallel to the principal axis. So here you can see the reflected ray is parallel to the principal axis. So isn't it very simple? The first one, it is totally opposite of it, right? Coming to the last rule, the third rule. The third rule, it says, if the incident ray passes through the center of curvature, then the reflected ray traces the same path. Let's see how to make it. What does that mean? If you have an object here labeled as AB, and if the incident ray passes through center of curvature, that is C, then the reflected ray traces the same path. It means that it is the same way. So you have to just make one more arrow like this. So the incident ray in the downward direction, the reflected ray in the upward direction. That's the only thing. So you just make one line and make 2 arrows in downward and upward direction. So they are the 3 rules for making ray diagram. Let's revise the 3 rules for making ray diagram. The first rule, I want your help. Okay. The first rule, if the incident ray is parallel to the principal axis, then what happens to the reflected ray, students? Yes, the reflected ray passes through the focus. Okay. Coming to the second rule. The second rule, as you all know, if the incident ray is passing through focus, then what about the reflected ray? The reflected ray will become parallel to the principal axis. Perfect. Coming to the third rule, which is very simple. If the incident ray passes through center of curvature, then the reflected ray will trace the same path, right? So they are the 3 rules for making ray diagram. Thank you. Now students, coming to a very important topic from your exam point of view, that is common terms related to spherical mirror. Let's start with the common terms. Now in common terms, we are going to understand concepts related to spherical mirror. That is, here we'll see some important definitions related to spherical mirror. Coming to the first thing, for making a spherical mirror, we all know we require a transparent sphere. After that, we have 2 mirrors. That is, first, this one is the convex mirror, right? Okay, now guess which is the second one. This is the concave mirror, right? So we have the 2 mirrors. Now, you must have studied this in geometry. Every sphere, it has a center, right? So the center here is marked with capital C. And this capital C stands for center of curvature. Coming to the definition of center of curvature, it's very simple. The center of the sphere of which the mirror is a part is the center of curvature. I repeat, the center of the sphere of which the mirror is a part is its center of curvature. Coming to the second definition. Now here you can see the mirror, it also has a center, and that is denoted by capital P, and capital P stands for pole. Let's see the definition for pole. It's very simple. The center of the spherical mirror is called as the pole. Of the mirror is pole, right? The next definition is principal axis. Now what is principal axis? If I make a straight line from C to P, that straight line passing through center of curvature and pole is called as the principal axis. So let's see the definition for it. The definition, it says the straight line passing through the pole and the center of curvature of the mirror is its principal axis. It's very simple, right? The first three definition. Coming to the fourth definition, radius of curvature. Now you all know what is radius, distance from center to the circumference. Now here if you see the distance from C to P, that is from center of curvature to pole. So the definition, it says the distance between the center of curvature and the pole of the mirror is the radius of curvature. Now these are the four definitions. Moving further to the next definition. The next definition is for principal focus. You will hear the word focus constantly in 10th standard, right? Focus on your studies. What do you mean by the word focus? Focus, it means to concentrate. Now here, what exactly is the principal focus in spherical mirror? Let's understand. We'll understand first for concave mirror. We'll consider a concave mirror. Now students, capital C, you know it stands for center of curvature. Then capital P stands for pole, and the straight line passing from C to P is principal axis. Now if I make parallel rays of light incident on the concave mirror, what happens? Let's see. We say rays of light parallel to the principal axis. After reflecting from the mirror, what happens? Let's see here. So we say after reflection, the rays meet in front of the mirror at a single point. You already know that concave mirror is a converging mirror, right? So the rays are meeting in front of the mirror. Where the rays meet, it is called as the focus. So where all the rays come and meet, that point is the focus. Now how to define focus? Let's see. It's very simple. The rays parallel to the principal axis get reflected from the mirror and meet in front of the mirror at a single point. It is the focus of a concave mirror. I repeat, the rays parallel to the principal axis get reflected from the mirror and meet in front of the mirror at a single point. It is the focus of a concave mirror. Coming to the next definition, focus of convex mirror. Here we consider a convex mirror. Again, center of curvature. After that, pole, and finally straight line, the principal axis. Now students, when rays of light parallel to the principal axis, what happens here? Let's see. Rays of light parallel to the principal axis, it gets reflected from the mirror. And we know convex mirror is diverging, right? So what happens here is the rays diverge. Now, if I want to make the rays meet, what I have to do is, I have to make imaginary dotted lines behind the mirror. So basically the rays are not meeting on their own. It appears to meet behind, right? So that is the focus. So we say after reflection, the rays appear to meet behind the mirror at a single point, and that point is called as the focus of a convex mirror. So coming to the definition it says the rays parallel to the principal axis get reflected from the mirror and appear to meet behind the mirror. It is the focus of convex mirror. If you compare the definition, it's similar. Only here it appears to meet behind the mirror. There we say they meet at a single point in front of the mirror. Now students, there in concave mirror, the rays are actually meeting, right? So as the rays are actually meeting, the focus that is formed is a real focus. But if you see in convex mirror, the rays are not actually meeting, right? What we did was, the rays are appearing to meet. So because they appear to meet, what we say is the focus is a virtual focus. So there are two focus. In concave mirror, the focus is a real focus, and in convex mirror, the focus is virtual focus. Coming to the last definition, that is focal length. How to define focal length? Let's see. The distance between the pole and the focus is called the focal length of the mirror. So it's very simple. The distance from pole to focus. Let's see for concave mirror first. So here you can see the distance from pole to focus is the focal length. If I see it here, again the distance from pole to focus is the focal length. But it is observed that the distance from focus to center of curvature is same as that from pole to focus. So even that is focal length. That is also same. If pole to focus is 5 centimeter, then focus to center of curvature is also 5 centimeter. Now students, we all know that the distance from pole to center of curvature is radius of curvature. So from this, what can you conclude? We can come to a relationship that is focal length is half the radius of curvature. So that is about focal length. So students, here we have completed the common terms related to spherical mirror, which is a very important part for your exam.